In this video, we're looking at 7.3, and we're continuing to look at hypothesis testing for the mean, but this time we don't know the population standard deviation. And so our sampling distribution actually isn't going to follow a normal distribution, it's going to follow what's called a t-distribution. But they are very, very similar, and the overall process is going to be almost identical. So the t-distribution looks like the normal distribution. There's just more content out in the tails. There's more data further away from the means. The tails are a little thicker. It's another way to think about that. The hypothesis tests are going to work the same way. If the sample is really far away from the mean, it's really far out in the tail, that means it has an unlikely chance of occurring. And in that case, we're going to reject the null hypothesis. So we're going to start off by finding critical values associated with different levels of alpha in the t-distribution. I'm going to show you how to do that in Excel. If you're doing a left tail test, you do t.inverse, you put in what your alpha is, and then your degrees of freedom. Degrees of freedom is always one less than your sample size. So just to do this example, alpha is 0.005 and our sample size is 22. So I'm going to have 21 degrees of freedom. So if I come into Excel and enter my alpha, enter my degrees of freedom, that gives me the cutoff mark where any critical value further away from the mean than this is going to cause me to reject my null hypothesis. It's giving me that t-value where only 0.005% of the samples fall even further to the left. And so for number 2 and 3 on the assignment, you're going to have to do a right tail critical value and a two tail. Excel always gives you back the probability of being to the left. So on the right tail, when it gives you back the negative, just make it positive. And then for the two tail, we're splitting that probability between both tails. We need to divide our alpha in half to get the cutoff line for each tail. And so I entered a value here just to show that. And when you hit enter, it gives you the left critical value, and you know by symmetry the right critical value is going to be just the positive version of that. So these would be the two critical values that our certain percentage, whatever our alpha was, is even further beyond in the tails. So number 4 is actually giving you a picture here, and it's showing you a critical value. It gives you a little number there, and then it's going to ask you about some test statistics and say, will you reject the null or not? Basically, if your test statistic is larger than this, even further away from the mean, it's past the critical value, it's in the rejection region, and so you reject your null hypothesis. If the test statistics comes back closer to the mean, you're going to fail to reject the null hypothesis. So complete that for different values of your test statistic. 5 is the same way, just a two-tailed test. So if you're further away in either direction, you're going to end up rejecting your null hypothesis. Looking at number 6 now, we got a story problem. A used car dealer says that the mean price of a 3-year-old sports utility vehicle is $21,000. You suspect this claim is incorrect. So we already have his claim. It's that it's equal to 21,000. So we have our null. That's our statement of equality. That's what the mean is. Our alternative is going to be the complement of that the mean is not equal to 21,000. To test it, we're going to take a sample. We're going to sample 20 vehicles, and we find our sample mean and our sample standard deviation. And again, we need our sample standard deviation because we don't know the population standard deviation. All right, and now we know our level of alpha, and we're going to decide whether to reject or accept the null hypothesis. So we're going to need to find the critical values, and then our test statistic, and then determine whether we reject or not. So we don't have the population standard deviation, and that should be your biggest hint that you have to use the t-distribution, as that when you don't know the population standard deviation, you can't use the normal distribution. So we don't have that. We're told this is alpha. We have our sample mean, our sample size, and our sample standard deviation. Take all those from the problem. Now your sampling distribution, it's a t-distribution here, it's going to have the same mean as what we are assuming the population mean has. And its standard deviation here is based off our sample divided by the square root of our sample size. So we plug that in and we get this. So now we can do the test statistic for our particular sample. How far away was it from this mean? So we take the value from our sample minus the mean from the population, from our distribution, and divide by the standard deviation. We're seeing how far away our sample was from the mean. And it comes back to 1.86. Now, is that far enough away for us to reject? Because we're doing a not equal to for our alternative, we have to do a two-tailed test. So we're going to split our alpha between the two tails. That's for our not equal to. So to find what our critical value is, it's all based off of alpha. Alpha is 0.01. Divide that in half, divide it in two because there's two tails. And then we have to type in our degrees of freedom, which is one less than the sample size. When we hit that, Excel is going to give us the left critical value. I know by symmetry the right critical value is positive of that. So if we get our sample test statistic was anything further negative than this or further positive than this, we would reject. Now 1.86 is right in between these two. It's not further into the tails, so there's not enough evidence to reject the null hypothesis. If you want to think about the p-value approach, Excel has this formula, and you just type in your test statistic and your degrees of freedom. And this is for two-tailed, that's what the .2t means. And so the probability of getting a sample like we did, or one even further in the tails, is this right here, and this is bigger than alpha. So again, that's another test that reaches the same conclusion that we do not reject the null hypothesis. 7 and 8 are pretty similar to number 6. Try to set them up like this. Identify all these different parts. And then once you have those identified, you can find the mean and standard deviation for your sampling distribution, which allows you then to do the test statistic and based on your critical values, either reject or fail to reject the null hypothesis. Anything confusing, or if you have any questions, please let me know.